or it becomes easier for you to just refer to the periodic table, you know? So now this question is asking for the electron configuration for a phosphide ion. Okay, so now to answer this question, first I have to answer the question of what is a phosphide ion. So let's actually use other elements to be able to figure that out. We have NaCl. The name of that is sodium chloride, ending with IDE. Okay, so when things end with the IDE, okay, it means that it's just going to be the element of that element they're referring to, in this case being phosphorus. So phosphide ion would mean that, well, let's just start with what phosphorus is. So we know that now it's a phosphorus. Okay, so before we jump to solving for the ion, we first need to solve the electron configuration for phosphorus by itself. Okay, so that would actually be, okay, if we start it from the neon, oops, I don't like this color, neon, because I want to differentiate from the question itself, is going to be 3s2 3p3. Okay, now that means it's 3 away from becoming a noble gas. It could either lose 5 whole electrons or add those 3, which is where the ion comes into the play. Okay, because now to get to that noble gas setup, you really just want to throw in 3 more electrons. So it will be 3 more electrons added to that p shell, since the s shell is full. So for the phosphide ion, the electron configuration will be 3s2 3p6. That because it's 3 minus there, because when you add electrons, you actually it's a negative sign because electrons are negative. So this right here actually should denote the electron configuration for a phosphide ion. Okay, yep, 3s2 3p6. There we go. So it's a lot easier to gain those 3 than to lose a whole 5, hence why we jump up like that. This is correct. And now let's move on to question 19.